coordinate geometry of a line. I'm not going to deal with the midpoint. You can look at that yourselves. It's just the midpoint of a line segment, and you know the formula pretty well at this stage. Regarding the slope, you can say it's the rise over the run, or the change in the y's over the change in the x's, or the formula here, which is, your y2 minus y1 divided by x2 minus x1. And so if you're given 2 points, you can just plug them in and work out the slope. Sometimes you're given a slope, you're given a diagram like this one here, all right? You're given a slope that looks a bit like this one, and you're trying to work out the rise over the run here, or the slope. And what you do is you try to find on the graph points where it crosses the kind of an intersection of an x and y line. In this case, it seems to be here, and here is good ones. Now, there may be other ones as well, but I think those two are perfect. And so I would kind of maybe do this and go, I can see that the rise is the difference between 2 and 5. So the rise is 3. 1, 2, 3, and the run is equal to 1, 2, 3, 4, 5. Okay, between 6 and 1. So the slope of this is going to be the rise over the run, which is 3 over 5. And it's a positive slope, you'll notice as well. In this diagram over here, on the right-hand side, the slope is a negative slope. And again, I can see that the rise is equal to 3, the run is equal to 4. So this slope is going to be minus 3 over 4. The rise over the run, but it's a negative slope. This is an equation of a line. Lines are often given names as well. So this line here, for example, would be line K, and they might refer to that. They might say, what is the slope of line K? Or they might say, is point blah, blah, blah on line K. So the first thing we can do is we can actually work out, if I give you the value of, for example, if x is equal to 1, I say, so at x is equal to 1, what's the value, if that's 1, what's the value of y at this particular point? So I can say if x equals 1, what's the value of y? Y equals question mark. And I can work out what the value of y is, because I can go 3 times 1, that's x equals to 1, plus 2y minus 4 is equal to 0. And that means that 3 plus 2y minus 4 is equal to 0. Leave my 2y here and get my other two numbers across to the far side, which is 4 minus 3. And that means 2y is equal to 1, and it means y is equal to a half. So we've just discovered that when x is equal to 1, y is equal to a half. So our coordinate is equal to 1 comma a half. Another thing you may be asked to do is to verify if a particular point is on a line. So in this case, the question might be, is the point 2 comma 3 on the line K? So what we do is we plug in the values 2 and 3, and we see if it equals 0. So we're going to put 3 times 2, because x is equal to 2, plus 2 times 3, minus 4, and we check, is that equal to 0? It should be equal to 0. If it's on the line, it will be equal to 0. If it's not, it won't be. So 2 2's are 6, plus 2 3's are 6, minus 4, and that is not equal to 0. So 2 3 is not on the line. Okay. Now let's check if the point 2 minus 1 is on the line. So the equation is 3 times x, and x is equal to 2, plus 2 times y, and y is equal to minus 1, minus 4. Is that equal to 0? So we're going to get 6 minus 2 minus 4, and that is equal to 0. So yes, so the point 2 comma minus 1 is on the line. Okay, so that is on the line. That's how we check that. In this case, we're told that a point 3a comma minus a is on the line. It is actually on the line. So therefore, it's going to satisfy this equation. And by satisfy means is when you put in 3a and minus a in for x and y, you're going to get 0. All right? So let's do that, and we'll see what it looks like. So we're going to have 3 times x, and x is equal to 3a. And we're going to have plus 2y, and the y value is equal to minus a. And we still have our minus 4. And we know that that's equal to 0 because we're told it is on the line. Now let's multiply it out. 9a minus 2a minus 4 is equal to 0. And that means that 7a minus 4 is equal to 0. I'm doing this slowly. 7a is equal to 4. And that means that a is equal to 4 divided by 7. There are probably 3 main scenarios to help you that you encounter when you're trying to find the equation of a line. Those are the 3 there. Let's have a look at them one at a time. Okay, so the equation of this line is y minus, and y1 is equal to 2, is equal to m, is equal to 6, x minus x1 is equal to 3. So this formula is in the formulas tables book. So y minus y1 is equal to m into x minus x1. That formula is in the formula tables. You should have a look at it before the test, make sure you know where it is, etc. So anyway, y minus 2 is equal to 6 into x minus 3. And then you just multiply this out. It's equal to 6x minus 18. Now we write the equation in standard form. So we're going to leave the 6x here. I'm going to subtract y from both sides, so it's minus y. And when I subtract y from this side, that's going to go. And I add 2 to both sides, so it's going to go there as well. So minus 18 plus 2 is equal to minus 16. And that's equal to 0. And that's my equation in standard form. The second scenario was trying to find the equation of a line when you're given a point in a parallel line. So we're given a point, for example, it'll say the line passes through the point 2, 3 and is parallel to the line x minus 2y is equal to 4. So we need a point and a slope. So we need to find the slope of this line here. Then we have the slope and we can do what we did in scenario 1. So let's get the slope of that. There are a number of ways to get the slope of a line. One way, which is quite nice, is to get it into the form y is equal to mx plus c. And whatever the number is in front of the x, when it's in this particular format here, is equal to your slope. So let's put our equation x minus 2y is equal to 4 into this particular format here, the slope format. I'm going to add 2y to both sides. It's going to give me x minus 4 is equal to 2y. What I did was I added 2y to both sides, so it cancelled this out here and I get 2y here. And then I subtracted 4 from this side and I subtracted 4 from both sides. It gives me an x minus 4 on this side is equal to 2y. So it's nearly in this format here, but I've got 2y, so I need to divide the whole thing by 2. So it's going to be x minus 2 minus 4 over 2 is equal to y. And if I rewrite that into form, I'm going to get y is equal to a half x minus 4 over 2. So m is equal to a half. Now at this point I have my point, I have my 2, 3, and I have my slope. So I just use what I did in the first scenario. I have a point and a slope. In the last example, I told you how to get the slope of a line. You can put it into the form y is equal to mx plus c. So you can do that with this as well. You can just rearrange your formula till it's in this format. Or another way to do it, it's another thing to remember, but it's really good. The slope is equal to minus a over b. And that is equal to minus 4 over minus 2, which is equal to 4 over 2, which is equal to 2. And if you rearrange it into this format here, you'll find you're going to get the value of 2. But it's much easier just to read off, whereas the 4 is the a and the minus 2 is the b. So it's minus a over b. Now that's the first step. The next step we need to do is we want to get the perpendicular line. This little shape here means perpendicular because the line is coming down at 90 degrees. That's perpendicular. So what is the line which is perpendicular to 2? Well, it's the negative reciprocal. So if the slope, if m is equal to 2, well then m, I'll do a little perpendicular sign here, is equal to minus a half. Okay, I'll put a little. Okay, and what these mean is that if I multiply 2 by minus a half, I get minus 1. If two lines are perpendicular, the product of their slopes will be equal to minus 1. So now we have a point called 1, 2, and we have a slope minus a half. So there we're back to the first scenario again. To find a point of intersection of two lines, for example, 3x plus y is equal to 5 and x minus 2y is equal to 3, I'm going to use a thing called a simultaneous equation. And I can find out exactly where these lines cross over. So I'm going to take the first line, for example, let's say x minus 2y is equal to 3. And the second line is 3x plus y is equal to 5. I can choose what to do. I'm going to multiply this line here by 2. And the reason I'm doing that is it's going to turn this y into plus 2y. And then I can cancel out these two here, you see? So let's multiply this one by 2. It's going to give me 6x plus 2y is equal to 10. Now I'm going to write down this one again underneath it. X minus 2y is equal to 3. Let's add these up. I'm going to get 7x. The 2y and the minus 2y, they cancel each other out, is equal to 13. So x is equal to 13. divided by 7. In your test, I just made this up a moment ago, in your tests, the numbers will be nice whole numbers, I guess. 13 over 7 is obnoxious. So I now need to work out what the other value will be. And I'm going to put it into this now. We go here. I have x minus 2y is equal to 3. So I've got 13 over 7 minus 2y is equal to 3. Isn't this terrible? I've got minus 2y is equal to 3 minus 13 over 7. Put into calculator, guys. 3 minus 13 over 7 is equal to, I know that 3, by the way, is equal to 21 over 7. So 21 over 7 minus 13 over 7 is 8 over 7. So minus 2y is equal to 8 over 7. And so y is equal to minus 8 over 14. I hope you're impressed with that. So y minus y is equal to 8 over 14. And that means y is equal to minus 8 over 14. As I said, the examples you would get would be a lot easier than that. That's sort of horrible. But the main thing to focus on is you do a simultaneous equation, you solve for x, you solve for y, and the point of intersection is 13 over 7, comma, minus 8 over 14. Yuck. Sorry about that bad example, but I hope you get the idea of how you would do it. Right, a couple more examples of how to get slopes. First of all, your line will be in this format. Ax plus by plus c is equal to 0. The most important thing is that it's ax plus by. You don't really matter where the c is or what value it is. It's an irrelevance to the slope. And m is equal to minus a over b. The other format, of course, is in the slope format, which is y is equal to mx plus c, in which case your m is the slope. Notice, by the way, if you have something like 2y is equal to 3x plus whatever, doesn't matter, you have to divide this by 2. 3 over 2x. And who cares what that is? It doesn't matter to the slope. So our slope in this case is going to be 3 over 2x. So 3 over 2 is the slope. Okay, so let's do it with these ones here on the left hand side. X minus 3y is equal to 4. I have an ax and I have a minus 3. So the slope is equal to minus a over b, which is equal to minus 1 over minus 3. That's equal to 1 over 3. The minus over minus gives me plus. Again, I have ax, by. It's in that format. I can just use it. So that's equal to minus 2 over 5, the slope of this one. You notice the minus 7 is an irrelevance to the slope. Okay, y plus 2x is equal to 3. It's not in ax plus by, but it's very close to this format here, isn't it? Very close to that one. So let's leave it like that. So I'll do it in green. So y is equal to minus 2x plus 3. So in this case, the slope is equal to minus 2. Now here's a format here, the last one. This here, I'll wrap it in red. It's not in either format. It's not in ax plus by plus c. It's not in that format. Neither is it in the format y is equal to mx plus c. You have to choose to put it into one of them. I'm going to bring my add y to both sides. Okay, so that'll be the effect of add y. So I'll leave the 3 here. Going to be plus 2x is equal to y. And that means y is equal to, I'll do it in green, y is equal to mx plus c. Okay, interesting, you know, it doesn't really matter what the position is of the, I don't have to have it written like y is equal to mx plus c. In this case, I have y is equal to mx plus c. And they're both the same. So the slope is equal to m is equal to 2. Okay, there's a few examples for you. Good luck with all that.